Hi everyone, welcome to the MrpTech Podcast. This is episode 121. My name is Matt, and this is the weekly podcast discussing everyday tech for everyday people. The topic for this week's show is distributed computing. I'm going to get into that in a few minutes, tell you what that is. But before that, the last few days have been kind of this crazy journey that started with one idea and ended up being something completely different by the time that I was through with it. So earlier this week, I had the idea, I'd like to go back and check out BSD. It's the Berkeley software distribution, similar to Linux. It's a Unix-based operating system developed at the University of California, and sort of the basis for things like True OS now, originally the basis for Mac OS, along with countless other operating systems. Even the PlayStation operating system, I believe, was originally based off of BSD. So I wanted to go check that out because I had this crazy idea that with this student tech lab that I have built at my school, we have lots of different things in there now, but I never gave BSD a chance and I hadn't installed it on anything. So did a couple of things. I went and checked out the BSD website. I remember years ago PCBSD, and I wanted to try that again, and came across True OS, which is now the new name of PCBSD. Downloaded the ISO image, put it on a flash drive, tried to boot it up on the computer, wouldn't boot up. Tried it from a different computer, downloaded a new image, put it on a flash drive, tried to get it to boot up on a computer, would not boot up. Tried this a few times on Windows, on Mac, on Linux. Couldn't get the True OS image to boot for any reason. I got other OSs to boot, but not this one. So I had to give up on that for the time being. I actually ended up installing Fedora on the machine that I was going to use, but I'm familiar with Fedora. Wasn't my original plan, but that's what's on there now. That may change in the future. So I'll come back to BSD in a little bit. So oftentimes when I'm driving to and from work or kind of walking down the hall, usually I'm stuck deep in thought about certain projects or certain ideas. And sometimes they just kind of pop into my head on how to try new things. This week, I want to talk to you about distributed computing. So distributed computing, you may not be familiar with it right off the bat. And the definition doesn't really help at all. But I'll give you the definition of distributed computing. Distributed computing is a field of computer science that studies distributed systems. So these are components that are located on different networks. Then they communicate together, coordinate their actions, and passing messages to one another, which basically helps solve a common issue or a common goal. To give you the best explanation of distributed computing, I'm going to talk to you about one of the largest and longest running projects that's out there. That's SETI at Home, the search for extraterrestrial intelligence. Now, just kind of doing some light reading before the podcast started, I didn't realize that SETI basically is not one large organization, but it's a group of smaller organizations that have the same goal. And back in 1999, and actually the years leading up to 1999, they had an idea of, they have so much data that they gather from telescopes, they gather from all around the world, that their servers just can't handle that data. And if they were able to get a group of people who volunteer to donate time on their computer at home, then they would be able to sort of distribute these tasks that need to be done. And instead of purchasing something like a supercomputer to do these tasks, you can connect all these computers over the internet, and it's like the same idea as a supercomputer. And basically, the idea is for those who leave their computer on, you can leave this program running, and when the computer is not being used, then you can use CPU cycles and things like that to analyze all the data that needs to be done and then send it back to SETI, which happens to be its main sort of base of operations happens to be at the Berkeley. So basically, they have tons of data. They need everybody to analyze it, and you can participate in this program for free. Let's say you leave your computer on most of the time. It's sitting there idle. Rather than just having it not do anything, you can have it be a benefit to certain projects. Now, SETI is just an example of one of the first organizations out there to do this. There was a few other organizations before that did this. But SETI quickly became one of the largest. Now, they expected if they could get 50,000 people to do this, then they could actually make progress with the data that they have. So it turned out quickly that they originally had not only 50,000, but close to a million people doing this. And now I believe it's up to around 5 million people that do this. Somewhere between 1 and 2 million actively using the SETI at Home software, and 5 million downloads and installs. So if you're somebody who wants to be part of a larger goal or larger vision, but don't have a whole lot of time, you can use distributed computing to basically donate resources from your computer to help those goals. Now, gave SETI as an example because they're one of the largest ones that's out there. Basically, here's how it works. So there is a piece of software that's available for just about anything. And I always pronounced it wrong because I wanted to call it BOINC, but it's actually pronounced BOINC, BOINC. Now, what that is, it's an acronym. I'm not exactly sure what it stands for. I've heard it several times, but I don't have anything up here on my screen. But okay, so BOINC is a platform for high throughput computing on a large scale. You can scale it from a few computers to millions of computers. It's used for volunteer computing, basically using your devices, or grid computing using organizational resources. And you can run this in virtualized machines. You can run it on actual hardware. And it's distributed under the LGPL open source license. It can be used for commercial purposes and applications, and it doesn't have to be open source. So BOINC is sort of the software that these companies will use to connect all these different computers around the world together. So if you were to do something like Google SETI at Home, and that's the SETI at symbol home all together, no spaces, the first thing that you do is you'll need to sign up. And it is really easy. It is painless at all. Basically, provide an email address, you make a password, you're done. That's all it is. No activation other than that. And you can download BOINC for whatever computer you're using. You install the software. Basically, it's a very simple interface. If you are behind an organization's proxy settings, you have to set your proxy settings first. If you're not, then you shouldn't have to do anything with that. There's a drop-down menu where you can do that. You can also set things like when you want BOINC to be running. So let's say you only want it to run when you're not using the computer. You can set that in one of the configuration settings. You can also set it to only use up a certain percentage of the CPU on your hard drive, or the CPU, only a certain percentage of your CPU. And I set it at about 75% because I didn't want my CPU blasting at 100% every single second of the day when I wasn't using it. So, and you can also set it to only use so much of your hard drive space because it is going to analyze data and then it's going to send the data back to the company or organization that you are helping out. So set that, and then you can add from this this piece of software, and I think I called it BOINC again earlier. It's BOINC. That software, you can add the projects that you're interested in. So when I did this on an old Windows computer earlier today, I had a problem with it not recognizing the links that it tried to connect to. And if you have that problem, what I did is, because it shows you a link and then you just hit connect. But the links, most of them are all HTTP links. And I just happened to try it. I put HTTP and then I added an S, because a lot of the websites, I'm sure, have gone to HTTPS over the last year or so. And once I did that, I was able to connect and add the project. And then it connects to their servers and starts working on a project if there's one available. If there's not one available, it says no projects at this time. So let's talk about the types of projects. We've already talked about SETI at Home, and it's been running since 1999. Basically what that does is it helps analyze space-based radio signals for signs of intelligent life. Now, there are other things in astronomy that you can do. So you can analyze data for incoming asteroids, which many people think is a big deal. You can help discover gravity waves and sort of help predict. They were predicted by Albert Einstein, and you can help gather data and analyze data for gravity waves. There are other ones. Okay, so those ones were called Orbit at Home. That's the asteroid one. And I believe the Einstein one is called Einstein at Home. You can also gather information for modeling galaxies formations or the universe's formations. Milky Way at Home, Cosmology at Home. Those are the names. But the skills and uses of distributed computing goes far beyond astronomy. For chemistry, you can analyze data to increase the efficiency of solar cells. So that's first attempted by the Clean Energy Project. Things like biology, you can be a part of the DNA at Home project. And this is trying to better understand the gene regulation and transcription, how cells turn on and off. Things like helping to find cures for diseases. Folding at Home is one project that's been around forever. And basically it has to do with the incorrect folding of proteins, or a small problem in its overall shape can cause serious health problems. So this has helped studies for like Alzheimer's disease. And Rosetta at Home is a project that basically creates three-dimensional structures of proteins and basic amino acids. And then they study the proteins involved with diseases like malaria or HIV and other different patterns. And their hopes is to, over time, be able to create cures for diseases. And they need computing power in order to do that. There's other programs fighting AIDS, fighting childhood cancer, helping to fight muscular dystrophy. A big thing is collecting climate data, whether you're someone who denies that climate is man-made or you agree that climate is man-made. This can collect data, and over time, that data will become science fact, and hopefully help to educate those out there towards whatever the result is. There are also there's basically distributed computing for just about everything. I mean, you can help physicists simulate particle accelerators, and basically they take the scientists at CERN can simulate things that the Large Hadron Collider will do and help sort of tweak its performance in a simulation before they actually apply it to the Hadron Collider itself. So the list goes on and on of all sorts of these programs that out there that I had no idea existed. And this all came from me as a thought as I was walking down the hall of something else that I could add to, say, a tech room or something like that, that would be beneficial not only to the students here, maybe the local community, or greater. And so I haven't really decided exactly which ones that we're going to do first, but basically you can all do this from this BOINC software, the BOINC software. And it's very easy to install. If you have an Android device, there is an app that you can download, that you can do this on your Android device. And basically, think of the millions, if not billions, of Android devices out there. All of these resources, all of these phones that are now becoming more powerful than our desktops or laptops, and connect them all together. And imagine what we could accomplish. Imagine what we could accomplish if schools got involved and started giving some resources to these organizations that need help. Or just at home, if you have a computer that's on most of the time and it's not being used, why not donate some cycles of your processing power of your computer, and you can actually set the times that this does it. So it doesn't need to be run 24 hours a day, but you can set the time that you'd like it to do. Maybe you want to do it at night, maybe just a couple hours here or there. So it's a really neat project. And what I didn't realize is as I was researching this, yes, the SETI at Home project is located at Berkeley, but this whole open software, BOINC, that software is coming from scientists, and they've created this project so that others can use it. It could be for small projects, it could be for large projects, but it's all coming from Berkeley, which is really cool because I was originally this whole idea came from BSD, the Berkeley Software Distribution. What a completely random series of events that led me from one thing created at Berkeley to a completely other thing that I really had no knowledge of before. And I have heard of SETI at Home for years, and I never really tried it out. In fact, the first origins of SETI at Home was basically like a screensaver. When your screensaver came on, that's when it kicked on and started doing the research that it needed. Now it's a little bit different using this software, but still coming out from Berkeley, which is really neat. I'm going to put links in the show notes because there's at least, 50 different projects that's out there. And with all of these projects, you're benefiting for the larger good. And I've never done this before myself. I've heard about it for years, never done it. I encourage all of you to check it out. It does take up processing power on your computer. And if you're using your computer, you can set it so that it basically suspends working on those projects. And then after a certain period of time when you're not working on your computer, it starts up again. So that is something I encourage you all to check out. Find a project that you're passionate about, whether it's searching for asteroids or trying to cure cancer. All it takes is, that one person or group of people to have the time to discover something that will change the world forever. And the more people that do it, the more, the quicker that this will come. One of the things that I came across from the SETI documentation was that now with these million users, okay, every single day they go through basically 1,700 years of what it would take one person to do, gathering all of the data. That's pretty incredible. So they basically gather satellites. They don't actually rent the satellites out, which I thought was kind of interesting. I never heard it before. They actually just, if someone else is doing research and they're pointing a telescope somewhere, then they can take that data and they will analyze it themselves and for what they're looking for. Kind of cool. So I wanted to talk about this today just because this wide swing that this took. I was originally planning on talking about BSD a little bit, and all of a sudden BSD didn't work out, and through one strange way or another I came back to Berkeley. It was weird, and I thought it was a cool topic. So I'm going to put all these links in the show notes for you. If you have any questions, send me an email, mrptechreviews@gmail.com. And just some housekeeping stuff here to talk about real quick. Over the last few months, I have been trying out the Amazon affiliate thing. I have to say I'm not very pleased with the Amazon affiliate project. And the more that I learn about it, the more that I realize that this isn't right for me. And if something doesn't feel right to me, then I don't do it. And the Amazon affiliate project is probably something that I'm going to shut down very soon, if not within the next couple of days. I don't like it. It has not been really beneficial in any way. And in fact, there are so many rules and regulations with Amazon that it makes it almost impossible for a content provider to get anything from it. And so I probably will deactivate that Amazon affiliate account. If you want to subscribe I should say support this podcast, I have a Patreon page. It is patreon.com/mrptech. And that's the best way you can support me if you'd like to support the podcast. It's not something that I ask for very often. If you're a listener, you've been listening for a while, and you really like the show, you really like the content I provide, then maybe consider going to that Patreon page. You don't have to. The best thing you could do for me is tell people about the show and get more people to listen. That's really what I want to do. To me, it's more about educating and, for me, learning and talking about things that I've learned. There are people out there that are far smarter than I am that talk about way more complex things. But if you like what I talk about and you want to support the show, patreon.com/mrptech. On top of that, there are other great shows on the Podnuts Network, and everything from Linux topics to computer repair to system administration to single board computer shows to people who are interested in making things. They're really great shows. If you haven't listened to them yet, go to podnuts.com and check out those shows. With that said, that's going to do it this week. Thanks everybody for listening. We will see you next time.